Let's build a platform for open science using just Docker Compose. Let's get started. So first of all, we are going to put together a lot of small pieces, small containers to build up a complete platform, meaning that we need a JupyterLab instance somewhere where we can put data, so an object storage in this case. We need also some kind of mechanism to send our data from our experiments, so kind of a message queue. And we are going to use Nets for this. We are going to see how it works in just a few minutes. And then, last but not least, we need some way to track our experiments. So we analyze data, we get information, insights on this data. We need to track what we did in the previous attempt, so we can try to play better and to have more sophisticated pipelines for our analysis. In other words, we need more containers to work together as a unique component. So we need to merge and to orchestrate, in a certain sense, more containers to provide something more, a platform in this sense. We are lucky enough that we have a real-world example, because we are going to dive into a platform that we set up at INFN for some of our courses. One of these is an open science computing on cloud that is called SOSC, and it recently happens just in October. So I took inspiration from there, and we can reproduce what the actual students played with. So we start here with a JupyterLab instance. So you see that for orchestrating via Docker Compose, you just need one file called Docker Compose, and in the format YAML that we will see, and I put the reference for that in the description. Every container, every piece of the puzzle that we are going to put together, it's called a service in Docker Compose terminology. For JupyterLab, for example, we can decide that, all right, maybe I just want to put in place the Docker file that we produced in the previous episodes. If you remember correctly, what was that? It was Docker, a Docker file like this. So simply taking a SciPy notebook and installing some extension, and plus putting inside a demo notebook, simple demo notebook on NumPy and Matplot, and that's all. So I want to use that. How you indicate this in Docker Compose? Simple, like I want to build, I don't want to use a pre-built image, I want to build it looking at context, Docker file, and that's all. So I put the context and the Docker file name, and I'm ready to roll. Then I want my service to be accessible from outside. Be careful, expose and parse have different syntax. What you want when you want to expose your service is using parse, so binding the internal port exposed by your service to the external one. Then you have every command that you might want to port from the Docker run that we did last time. So for example, you can decide a custom command to start the notebook with, and also you can import environment variables from a .env file. So we can put here all the secrets, all the information that we want to be configurable in a central place. And eventually, you can also add to that explicit reference to environment variables that you want to appear there and not in the configuration file. So, first component is done. First component is done. Now we need the second one, that if you remember correctly was the object storage. For the object storage, we use min.io. Min.io is de facto the way to go if you want a quick and easy way to obtain an object storage out of the box, just with a folder and that's all, and you want to be able to use S3 APIs. S3 APIs are APIs brought from AWS, so in principle, if you're able to play with min.io, you can port your environment wherever you want, especially in an environment like AWS, so public cloud in this case. For this reason, also at the school, we provided min.io out of the box, and it was simple, like taking the instance, the default, taking the default container, and then doing the commands that are needed, exposing the ports, and that's okay. I mean, it's very similar to what we did before, except that we pass a pre-built image. The last step are respectively MLflow and Nets. So you can see here there is nothing new. For MLflow, we use a particular image because we want to integrate the experimenting traceability provided by MLflow framework. So exposing a service where you can track all your experiment, construct your pipelines for data analysis, and store your so-called artifacts. So all the piece of information that you want to store permanently from your analysis in an artifact store that with no surprise will be our min.io instance. So we need to integrate MLflow with S3, and we need then to import some particular packages inside the default image for MLflow. And in fact, the Docker file that we refer to in the Docker Compose is essentially taking the default image and installing Bo23, that is a Python library to interact with S3 compatible storages. Then, all right. Then we have the last piece of the puzzle, that is the Nets infrastructure. So we need a service that, for example, our experiment that is taking data can send messages, okay, these data are available, you can process it. This is what we used and we show in the school. So if you are interested, if you are a student, or if you have a student that you want to send, just stay tuned for the next edition next year of the school. And what we did is Nets, what we did is we use Nets, that is a Go-based implementation of we use Nets, that is a message queue, very efficient message queue system where you can apply different paradigm of starting, for example, in this case, for the school, we use the simple pub sub information propagation. So that's one way to go. And you have to open the port for this service, of course, to specify some authentication via a server configuration that we pass. This is an interesting thing that comes at the end. We are also able to mount specific configuration file in this way, just like we did, for example, for the JupyterLab persistent storage. And in particular, volumes here stays for the command docker -v, if you remember, that bind mount the local directory inside the container. And what we are going to bind mount is a configuration file that we put here in the very same folder, and it's simple like that. So we indicate the port and a token for the authentication with the service. That's all. So we have a complete single user platform. We are going to look at we are going also to look at how to adapt this kind of platform for multi-users. So using a container orchestration that you might have heard that is called Kubernetes. We will have deep dives into Kubernetes environments. We will see different layer of abstraction that you can build on top of that. But so far, so good. Let's proceed with a Docker Compose and let's see what this provides us. And let's see how the whole thing works. So we now have to try it out. Simple. We now have to try it out. crazy simple. You can see here, you can do something like going into the folder that hosts your compose file, do docker compose app -d, and that's all. It will look into the local folder for a file called docker-compose.yaml, and it will run and execute all the services together, being particularly careful on keeping them alive, so you will be prompt for all the status of your containers. Alright, so everything started, and you can see how the deployment goes via docker compose ps, and you can see now the printout is not that useful, but you can see that we have a JupyterLab up and running, exposing port 888, and in fact we are going to look at what we have here. So, oops. Alright, we have our token to be passed, and the token that we stored here in JLab token was this one. This is just an example. So we copy, paste, and we are inside our container. So you look how crazy simple it is. You have on your local laptop a complete environment where you can play with all the technologies that are useful, at least to start understanding how you can build your analysis pipeline. So notice that the demo notebook is here. You can even try if everything is installed, and in fact is perfectly working. Then let's go ahead and take a look at the next service. The next service is the Mina.io service that exposes the API for interacting with Bot3 client on the API to interact with the Bot3 client at this port, and also an additional port that is the one for the graphical web interface. And the graphical web interface is here. We forwarded the port from our remote host, and here it is. You have your Mina.io instance. You can take the username is admin, and the password is this one. So admin and this one, and voila, we are in. We pre-built a bucket, and we have our screenshot. All the data are stored on the volume that we mount here. So for Mina.io, we put into data, local folder data, all the metadata and actually files that we load into the buckets. So you can see here, I did upload something before. I then brought down all the Docker's containers, and nothing happens. I mean, as soon as I did Docker Compose app again, the data were saved there, so the server just restarted as it was. The server just restarted with the state that had before the shutdown. Alright, cool. Then, just for a complete review, let's take a look also to this one that for network reason we need to call like this. And here you have also an MLflow interface, completely working interface that you can start to use immediately from inside your notebook. Next, we are going to look at how it works in a dedicated video, so don't worry, Just keep in mind that if you are familiar with that kind of technology, the message queues, you can also use that, taking all the information from this Docker Compose that I put into the repository that I pass into the description. So we are coming to the end. I hope you enjoy this reference, so you can start from here and you can do a lot of more complicated stuff. But again, as always, at least for me, the important stuff is getting started with some end-to-end examples so you can have all the knobs later to intervene and to do all your nitty-gritty changes to all the configuration, and also, for example, to the demo notebook. You can do a lot of things more than this, but instead, if your needs are not too much complicated and you want to get started soon, this is perfectly fine for you to take it as it is and deploy it on your laptop. In the next episode, we are going to see how new technologies are emerging that will allow you to take this Docker Compose and say, I don't care about learning a new orchestrating mechanism like Kubernetes that can be very complicated if you want to understand it very well. I don't care about that. I just want this to be brought into a cloud system based on Kubernetes. How you can do that? Well, the closest thing that is happening recently is called Acorn. So we are going to look how you can import this information into the Acorn runtime. And I'm going to show you also the service that have been provided by Acorn people for you to try it out without the need to have access to any public cloud, just with a sandbox that will be provided by you for free, and you can use to start playing with that. You will have, of course, some limitations. Your containers won't last more than 2 hours, but you see that with some persistence, this is not a problem. You can perfectly start working, look around, understand how it works. And if it's okay, you can go further, and we are going to see also how to replicate this on a Kubernetes cluster of yours. So if you click a button on some public cloud, you will have a Kubernetes cluster available. You can deploy that there. So stay tuned because more fun is coming, and subscribe if you want to stay updated.